In this example, I want to find the projection of the vector b onto the vector a. So when we're talking about a vector projection, is that what I want to do is to combine the direction and the length. Okay, so in other words, I'm going to have a scalar that is the length of the projection when I move b onto a, and then I'm going to multiply that by a unit vector that is in the direction of a. Okay, so that every vector has two components, a length and a direction. So the first thing to do is let's look at what the length is. So to find that, I know that that scalar component of the vector b projected onto the vector a is the quotient of the dot product of the two vectors over the length of the vector a. Okay, if I write that all in dot product notation, is that I end up with these two components. So one thing I need to do is to figure out that length of that vector a, and that's simply the square root of the sum of squares. So I can create that sum and find out that the length of the vector a is the square root of 14. So then all I need to do is just figure out what this numerator is, right? So that I can then put it all together and find the scalar component of this projection. So that's going to be what I'm going to calculate. I'm going to leave that 14 in the denominator, which is this length, and find that forming that dot product is that the length of the vector is the 3 over root 14. Okay, so that is my length. Next thing I want to do is find out my unit vector. In other words, I need to find the direction this vector is going to go in. And to do that, I've got most of that done already. So I'm just going to kind of go ahead and do my projection values here. 3 root 14, right, is my scalar part here at the top. And that I then am going to multiply that by a unit vector in the direction of a. Okay? So I already know what the length of a is. And so what I need to be able to do then, the next, is just put that in there so that I would then end up with 3 over 14 times the vector a. So all I did was combine this root 14 and that root 14 to get that denominator. Okay. So then when I just put in my vector a that we started with, I can find out that that projection then is the vector minus 3 over 7, reducing this 14ths, 9 over 14ths, and 3 over 14. And that is my projection onto the vector a.